10.27. Here we have a couple diagrams. These represent systems before and after reaction of two related chemical processes. Delta H for the first reaction is given, and we want to determine delta H for the second reaction. So this is kind of a conceptual question. So before, in the first reaction, before and after, so these are basically reactants and product. And so before the reaction, we have the reactants, they come together, they undergo collision, some energy is necessary to break bonds, and then energy is released when new bonds form. So before we have 4 red circles representing one specific type of substance, 4 green circles representing a different type of substance, and then on the product side there are 4 gray circles representing a different substance. So this would be like 4A plus 4B producing 4C. That's basically what that reaction is showing. And then they tell us delta H for that reaction is negative 595.8 kilojoules per mole. Right? So what that means is, first of all, when you see delta H or any delta H for any process, you look at the sign. What is the sign telling me? It's exothermic. It's releasing energy. It's giving energy. The system, which is the A, B, and C, the reactants and products, are exchanging energy with the surroundings. A negative sign means from the system's point of view, it's losing energy or it's transferring energy from the system to the surrounding. So this would be the quantity of energy transferred per mole of reaction, which would be 4 moles of A, 4 moles of B, and 4 moles of C for every one time I do this reaction as it's balanced. So then the question is, if I were to take this reaction what would delta H be for that? Well, that reaction is basically, well, it's not basically, it's exactly the opposite, where I'd be starting with the product and going back to the reactants. So because of the law of conservation of energy, if this top reaction was to release that quantity, if I were to reverse it and push it back in the opposite direction, I can't have any energy created or destroyed. So all of the energy exchanged from the system to the surroundings in that direction must have then gone back into the system from the surroundings if I go in the opposite direction. So the opposite would then be a positive 595.8 kilojoules per mole of reaction. So if I do a reaction that's exothermic, the exact reverse of that reaction will be endothermic with an equal magnitude, and vice versa.